Hi dear student, welcome to the classes. In this session, I am going to solve the previous year CET and NEET questions regarding the chapter haloalkanes and haloarenes. One thing you have to remember, dear students, whenever you are solving the NEET questions and CET questions regarding organic part, if you whenever you are solving organic questions, the questions are not specific. Means haloalkane, haloarene means they are not exactly means haloalkanes, haloarene. There comes questions, but very rare. They are asking the questions like, for example, one reaction takes place A, and what is the product B, and next what is the product C. If there are sometimes they are asking reagent also. This A they are asking regarding haloalkanes and haloarenes, and B is like phenols and aldehydes, and C sometimes they are asking IUPAC name. This is also regarding the past position knowledge. Therefore, whenever you are solving organic questions, dear students, you have to perfect whole organic chemistry, means one first PUC as well as second PUC knowledge. The minimum knowledge is sufficient for that whenever solving organic chemistry, but go for the inorganic and physical, they are not at all related to the any chapters. They are direct hit questions. For example, if they are asking thermodynamics, means exactly thermodynamics concept. If they are asking solid state, we completed solid state. If they are asking question solid state, means they do not relate and do not any intermixing of chapters. That's why all of them are going to prepare for first inorganic physical, then go for the organic. But one thing, those who are solving organic questions, they must and should become top, because everyone solving inorganic physical, but organic, those who are solving organic, his or she is become a topper. Therefore, while solving organic chemistry questions also important. Nowadays competitions is not that much of easy. Okay, this is what chapters and haloalkanes and haloarenes chapter, dear students. I will solve all the previous years. I will try to complete all the questions regarding the haloalkanes and haloarenes. You see here, first I will start 2018. One more thing, 2019 is there, but I don't get it right now. Okay, I will solve it, whatever it may be. One thing, in this organic chemistry, this haloalkanes, haloarenes, they are asking 3 to 2 questions. Means they are asking this year 2018 they asked 3 questions. Okay, we have to, therefore organic chemistry, whenever organic chemistry solving questions, means you have to perfect all. Okay, which of the following statement is true in case of alkyl halides? Alkyl halides means what? Alkyl halides means these are what? Alkyl halides, RX. These alkyl halides, which of the following statement is true? Means which is correct statement. These alkyl halides are polar in nature. In the first option only we have to see here, dear student. These alkyl halides RX, they are having charge separation, dou plus and dou minus. Therefore, if they are charge separable means we have to call that one as a polar. Already we discussed this point. Therefore, these compounds are called as what? Polar compounds. Next, if this is what statement true, okay, you have to see other 3 also. They can form hydrogen bond, they cannot form hydrogen bond. Then highly soluble in water, they are not soluble. They are soluble in water but not highly. Next one, they undergo addition, they does not undergo any addition reaction. Therefore, first statement is correct, they are polar in nature. Next one, N-propyl chloride react with the sodium metal in dry ether. You see here, dear student, they are asking N-propyl chloride. N-propyl chloride, and you see here N-propyl CH3, CH2, CH2, Cl. This is what methane, ethane, propane, and N-propyl chloride. Reactions with 2 mole of sodium, again 1 more chlorine, and this is 1 more propyl chloride, CH2, CH2, CH3. Therefore, we have to remove 2 sodium chloride. And next we are going 1, 2, 3, 4, 5, 6. Therefore, CH3, CH2, 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 CH2 and CH3. Dear student, how many carbon here? 3, 4, 5, 6. You see here 1, 2, 3, 4, 5, 6. Therefore, first option is correct. What is the name of this one? Methane, ethane, propane, butane, pentane, hexane. This is what name, hexane. This hexane and the name of the reaction, this vinyl alkyl halides reaction sodium, and this reaction is called as what? Wood's reaction. Dear students, simplest reaction they are asking, Wood's reaction. Therefore, this is what propyl chloride, it gives rise to hexane. Propyl chloride gives rise to hexane. Next question. One more thing you see here, dear student, when you are solving organic chemistry, if there are three carbon, that gives rise to 6. How much is there? It will give rise to that. If there are 1, it gives 2. 2, 4. 3, 6. Like double. You see here 3, therefore it is not correct. If it is 4, therefore it is, if maybe it is ethyl. Ethyl chloride is a reagent. If there will be 7, it is not possible. If whenever they are giving only one name, if propyl chloride given one means, propyl means if 3, it gives us to 6. Like that you have to know. Okay, next one, tertiary alkyl halide is practically inert. You see here, tertiary alkyl halide is practically, this is what a practically inert to the substitution by acento mechanism because of. You see here, tertiary alkyl halides means this is what a tertiary, this is what a CS3, CS3. Tertiary alkyl halides is practically inert to the SN. You see here, this SN2 reaction means we have to attacking up nucleophile, and this attacking up nucleophile, this is only one, this nucleophile is attacking in backside. Here there you see here, this is what crowding is more. Crowding more means this nucleophile is not attacking easily. Therefore, this is because of due to a steric hindrance. This is crowding. We are telling crowding. I explained this one in the SN2 reaction. These molecules, if this, therefore, whenever the SN2 reactions means the order of reactivity is primary is more reactive than secondary is more reactive than tertiary. Before that also it is methyl carbocation. Therefore, methyl carbocation, then primary, then secondary, then tertiary. Therefore, tertiary carbocation is very inert because it is steric. Crowding is more. That's why this is what there will be more crowding in the nucleophile attack backside. It is very difficult. Therefore, this order is follows by the methyl carbocation, primary, secondary, and tertiary. Next, we have to go for the next year questions, dear student. Okay. See here, in the following sequence of the reaction, you see here, that's why initially I told these type of questions they are not at all asked directly in this whenever asking the organic. That's why I solving this type of problems in this class also, in this video session. You see here, I will solve here downside CS3, this one here, dear student, this one, fourth one, this is what fourth one. Methyl bromide reactions with potassium cyanide. Whenever this CN, this is what a nucleophile CR minus attacking to this one, and this is, it gives us to methyl cyanide. This is what type of reaction is SN2. Next one, in this, you see here, this is what A product. You see here, this is A product. This A product again undergo hydrolysis, H3 hydrolysis. It gives us to this. In this again OH minus is attacking. This OH minus is again nucleophile. Again SN2 reaction. Therefore, it gives us to CS3 OH. CS3 OH. Again this CS3 OH. We are going for the lithium aluminum hydride. Lithium aluminum hydride means it is a reduction. The reduction means it gives attacking up one H plus ion to this one, and water is going outside. It gives us to methane as a product. This is what a reduction. The reduction means loss of oxygen. This is what when addition of hydrogen takes place. This is here this reaction. CS3 is here. CS3 OH is there. If we are adding H to hydrogen means it is going to attack CS3 OH2. This OH2 plus, this is going outside as H2 and H plus is attacking to this one. Therefore, it forms the methane as a product. Therefore, in this reaction, methane is a answer. Next one. You see here, dear student, that's why I am telling. Replacement of chlorine. I solved this one in one separate video. Replacement of chlorine by chlorobenzene to give the phenol requires a drastic condition, of course, drastic condition. But chlorine of 2-chloro-dinitrochlorobenzene, 2,4-dinitrochlorobenzene is readily replaced. This is because I discussed in this video. You have to see. I will explain this one in detail. You see here, what is that? In this chlorobenzene, the chlorobenzene, this is what chlorobenzene. This chlorobenzene, we are going to attack an sodium. If we are going to attack OH minus, this is OH minus is attacking this chlorobenzene. This forms the phenol. This forms the phenol, and it required a very drastic condition around 660 Kelvin temperature and 300 degree atmospheric pressure. We have required. This is what this is what a drastic condition. This is what a drastic condition. Whenever, if this chlorobenzene, instead of this chlorobenzene, if there will be chlorobenzene, 2,4-dinitro, 2 position and 4 position nitrogen is this nitrate group is there. If we are going for the NaOH attacking, this OH minus is replacing this chlorine. Whenever this reaction takes place, this nitrogen is like electron withdrawing group. Therefore, this is not required that drastic condition. It does not require any temperature condition, because I will tell you. It forms, this is what a phenol and this NO2 group, and this is what NO2 group attacking. Therefore, it does not require any condition, drastic condition, because of due to these electron withdrawing group. Therefore, they are very activating towards these electron, these ortho and para position. They are withdraws the electron in the ortho and para position. Therefore, these OH minus replaces this chlorine by OH very fastly. Therefore, from this you have to see here, the replacement of chlorine by chlorobenzene gives the phenol. Required drastic condition. But chlorine to 2,4-dinitrochlorobenzene readily replaces. This is because, that's why I explained this. NO2 group makes the ring electron reach at the ortho para position. It does not reaches. It can. Okay, next one. Okay, it can reaches. Next one, nitro group withdraw the electron from the meta position. Nitro group donate the electron from meta position. Nitro group withdraw the electron from the ortho and para position. You see here, just one, if it is OH attacking to ortho and para, what happens? This nitro group is there, na? This nitro group reaches this electron. Idu nodri, idu reach ittandre, this OH minus does not attack. If it is poor, means this will attack to this ortho position. This nitro group ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ this electron withdraw ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತಂದ್ರೆ this ortho and para position, they are very weak. They are very weak means then they are not at all attacking. They are attacking. They are replacing this. These type of reactions are called as ipso. Therefore, you see here, I explained this chlorobenzene. This is not at all a nucleophilic substitution reaction. They are called as ipso substitution reaction. Dear student, whenever haloarene does not undergo nucleophilic substitution, but you are nucleophile attacking. But if this nucleophile attacking and also chlorine releases immediately, it does not involve any step of reaction. It attacking and it is leaving. Therefore, it is ipso type of substitution reaction. Don't confuse this haloarene and involved in the nucleophilic substitution reaction. Okay, this is what electron withdrawing group. What happens? Their electron withdraws and they are deficient towards the ortho and para position. Therefore, this nitro group withdraws the electron in the ortho and para position. This is what correct answer, dear students. Next one. Is here, these questions are very important whenever you are solving the problems. This is what ethanol. You see, I will write here only. Ethanol, C2H5OH. This ethanol reactions with the PCl5. You see here, preparation of haloalkane from the alcohol. Preparation of haloalkanes from the alcohol. PCl5 first react with this one and it gives rise to C2H pi, next one Cl. I will write a direct product. By product I will not write because this is what my X. This is what my product X. This is X. Next, this one again reactions with alcoholic KOH. This KOH means this is a nucleophile attacking, OH minus is attacking, it gives rise to C2H pi, again OH, this is what again SN2 reaction. Again this one is reactions with H2SO4 at room temperature. Dear student, you see here first year in first PUC knowledge you have learned dehydration reactions, ethanol reactions with H2SO4, it gives rise to ethene. Ethanol undergo dehydration reactions. Ethanol dehydration, it gives rise to C2H4, that is what our ethene. It is what that's why I am telling, whenever you are solving organic chemistry, you have the previous knowledge also and previous chapters knowledge also. That's why whenever you are solving organic chemistry, you have to practice the first PUC knowledge. That first PUC knowledge is also very important. Next one, electrophile that participated in the nitrations of benzene. You see, this one everyone you know. Whenever this benzene undergo nitration in presence of HNO3, H2SO4, it gives rise to the product nitrobenzene. This is what NO2 group. NO2 plus is a, how this NO2 plus is generated? This NO2 plus, you see here, this H2SO4 reactions with HNO3, it gives rise to NO2 plus water plus HSO4 minus. Therefore, this is what electrophile, NO2 plus. This is what NO2 plus. Next, you see here. Next concept is whenever this hydrolysis of optically active 2-bromobutane, optically active 2-bromobutane, they are asking optically active. If this optically active aqueous solution, if NaOH, if with NaOH means SN 2-bromobutane, SN1 reaction. In this SN1 reaction, 2-bromobutane, it gives rise to what is the product? They are asking 2-bromobutane. 2-bromobutane means you have to write here methane, ethane, propane, butane. 2-bromo. This is what our 2-bromobutane. This one reactions with NaOH. NaOH, what is the product they are asking? That is very important. This optically active means these are what all are, this one you see here, this is what chiral carbon, therefore it is optically active. This one undergo in reactions with NaOH. In this, either it one involved in SN1 or SN2, that is very important. If it is, you see here, this is secondary. Secondary means it is involved very fastly with SN1 reaction. Therefore, if it is one optical active, it gives rise to racemic mixture, plus 50%, minus plus product 50% and minus product 50%. Therefore, it gives rise to butane. You are asking, this is 2-bromobutane. If it is NaOH, this one going to give alcohol, bromine replaced by CS3, CH, OH, CH2, CS3. This is what plus product means optically active racemic mixture. I am telling, this is what racemic mixture, CH, CH2, CS3, and this is what Br. This is what minus product. This is 50% and this is 50% plus product. Optically, this is what optical compound means, the left right compound 50%, right product is 50%. What I discussed in that day. Again, dear friend, you see here. That's why I am telling these whenever solving organic chemistry, that organic chemistry questions are very, very important. These are all interlinked questions. You see here, this gives rise to this product. You got it answer now. This is gives rise to plus and minus butane 2A. This is what cyclohexane, bromocyclohexane. It reactions with magnesium in dry ether. It gives rise to magnesium attacking to in this position. Therefore, MgBr. That's why I discussed the Grignard reagent. This Grignard reagent, this alkyl group, and this is what bromine group with Mg attacking to in between this. Therefore, cyclohexane, Mg and Br. If going to hydrolysis H2O, this H2O means it giving rise to one H plus ion and OH minus ion. H plus attacking to here, OH minus is attacking with this one. Therefore, it gives rise to one cyclohexane product plus Mg, Br, OH, dear student. Therefore, it gives rise to only cyclohexane product. Therefore, in whenever solving organic chemistry, you see here, this is Grignard reaction, again reactions with water. You already learned that preparation of haloalkanes from Grignard reagent in past position knowledge also. Therefore, organic chemistry solving, previous knowledge is very important. I will tell you plenty time also. Whenever you are solving organic chemistry, previous knowledge is very important. Next one, the arrangement of following. Arrange the following compounds. What are those? Bromomethane, bromoform, chloroform, dibromomethane. In the increasing order of their boiling point options, there is there 1 A, B, C, D. Increasing, they are asking increasing order of their boiling point. What are those? We have to first understand the bromomethane. Bromomethane means this is what CS3Br, bromomethane. Bromoform. Bromoform means this is what CS3B, CHBr3. Chloroform means CHCl3. Next, dibromomethane means CH2Br2. Dear student, CS3 bromomethane. Bromoform means CHCS3. You see here, whenever the bromoform, chloroform, iodoform also, one more is there. Iodoform means CHI3. Whenever you are getting bromoform, iodoform means form, there means there are three compounds, 3 moles. CHBr3, CHCl3. If dibromomethane, CH2Br2. They are asking increasing order of their boiling point. I explained that already. Boiling point is order of fluorine is less than that of chlorine, bromine, next one that of iodine. You see here, bromine is greater than chlorine, but here chlorine is there. Here out of 3 bromine is there. Among them, number of one more point. This is first point. Next one, number of bromine increases, again boiling point increases. If it is less than that of 2, if next it is greater than that of 3. Number of bromine increases, again boiling point increases. You see here 3 is there, here 2 is there, here only 1 is there. Therefore, first one is 2. First this one 2. Next one is 4. Next one is first. Therefore, you see here, this is what first. Next one is, this is second. Next one, this one is third, and next one is fourth. Therefore, first one, this one is here 2, 4, 1, 2. This is what our answer. Next one, which of the following is not true for SN1 reaction? SN1 reaction they are asking their student. SN1 reaction means we have to see this is a two-step reaction. Two-step reactions. Next one means it. You know everyone, SN1 means it is unimolecular reaction, means two-step reaction. It favored by the polar solvents. Yes, it is favors the polar solvents. It is polar protic solvent. I explained this one. Next, tertiary alkyl halide generally react through the SN. Yes, of course, tertiary is more reactive than secondary, than primary. I already explained this one. Tertiary compound more stable, tertiary carbocation. That's why this SN1 reaction takes place. The rate of a reaction does not depend upon the molecular concentration of the nucleophile. Very good. This is not true. Whenever you go for the rate of reaction, the rate of a reaction it depends upon only a reactant, a reagent. It depends upon only a reagent. It depends upon only reagent, but it does not depend upon nucleophile. That's why it is called as SN1. Therefore, it does not depend upon the nucleophile. Next, primary alkyl generally react through the SN1. Primary alkyl halides they are asking. Primary alkyl halides generally reacts through the. This here this does not. Yes, of course. This is also they are asking. This is correct question. This is correct. You see here when you are solving. The rate of the reaction does not depend upon the concentration of the nucleophile. Of course, it is correct. But primary alkyl halides reactions through the SN2. This is your CS3Br, primary alkyl halides. Nucleophile OH minus attacking backside because there is no any steric crowdons, only hydrogen is there. Therefore, it is what correct option is this one, D. Then next one, the conversion of benzene to acetophenone gives to the can be brought by, means what you see here, this is what our benzene, you see here, this is what our benzene, this benzene gives us to acetophenone. Acetophenone means this is what our acetophenone. This acetyl group is without attacking, means this is Priddle-Crafts acylation. Priddle-Crafts acylation means this is what CH3COCl in presence of AlCl3. Therefore, it is Priddle-Crafts acylation reaction, dear student. It's very simple. That's why they are confusing Wood's reaction, Wood splitting reaction, Priddle-Crafts alkylation, Priddle-Crafts acylation. That's why it is first PC concept. First year this one. Next one, dear student. An incorrect statement with respect to SN1 and SN2 mechanism for alkyl halides. Which is incorrect with respect to SN1 is SN1 and SN2 mechanism. Use here competing the reactions of SN2 reaction is rearrangement. Next one, you see we have to read for all this. Competing the reaction for SN2 reaction is rearrangement. A weak nucleophile and aprotic solvent increases the rate of favorable SN1 reaction. The strong nucleophile in an aprotic solvent increase the rate of the favorable SN2 reaction. SN1 reaction can be catalyzed by this some of the Lewis acid. You see here this SN1 reaction does not depend upon any catalyst. They are asking incorrect statement. Incorrect statement with respect to SN1 and SN2. This SN1 reaction does not depend upon any catalyst. Some of the Lewis acid and acid base also. These SN1 and SN2 reactions only depends upon nucleophile. Okay. It's very simplest question, dear student. Please, when you are solving organic chemistry, please throw out all your previous knowledge. Okay. If you like our tricks and shortcut, please share and subscribe our channels. Okay, next class notes I will start on the new chapter. It's very important and very easiest. Okay, thank you. On and on.